So, today we're going to unravel a truly remarkable story of biological engineering. I'm talking about a system that works perfectly for 9 months and then, get this, completely rewrites itself in a single breathtaking moment. We're talking about fetal circulation.
But let's start with a really basic question, one you might have wondered about. A fetus is surrounded by fluid, right? So how in the world does it get oxygen? How does it breathe?
And the answer is, well, it's pretty wild. It doesn't. Not in any way that we think of as breathing. Anyway, before birth, the lungs are basically offline. And that one simple fact creates this huge biological puzzle that requires an incredibly clever solution. I mean, think about it. If the lungs aren't working, your entire circulatory system has to be fundamentally different. You can't just pump blood to collapsed, fluid-filled lungs and expect anything to happen. So the fetus needs a totally different kind of cardiovascular highway, a temporary blueprint designed for a world without air. And here is the absolute hero of that system, the placenta. This amazing organ is basically the fetus's external life support. It's the lungs delivering all that oxygen-rich blood from the mother. But it's also the kidneys and the gut handling nutrients and waste. It's the whole shebang, an all-in-one support system. Now, to make this whole placenta-based system work, nature came up with a series of really ingenious bypasses or shunts. You can think of them like temporary off-ramps on that cardiovascular highway. They're built to divert traffic away from the areas that are still under construction, and that's mainly the lungs and, for the most part, the liver.
And how many of these crucial, game-changing structures are there? Just 3. Only 3 structures are the heroes of our story today. They're what make this entire pre-birth world possible.
All right, let's meet our key players. We've got the Ductus venosus, which creates a bypass around the liver. Then there's the foramen ovale, which is like a little secret door between the heart's upper chambers to bypass the lungs. And finally, the ductus arteriosus, another vessel that makes sure blood skips that pointless trip to the lungs. Each one has a very specific, very important job. So how does this all work together? Let's go on a little tour. We're going to follow the path of a single drop of oxygenated blood as it travels from the placenta all the way through this unique fetal highway. Okay, our journey starts at the placenta. Fresh, oxygen-rich blood leaves the mother's system and it travels towards the fetus through the umbilical vein. As it gets close to the fetal liver, it hits the very first of our 3 shortcuts. This first shortcut is called the ductus venosus, and its purpose is just fascinatingly smart. By shunting most of that blood past the liver, the system makes sure that this premium, highly oxygenated blood, the good stuff, isn't processed or used up. It saves that precious cargo for the 2 most critical developing organs, the heart and the brain. So, after zipping past the liver, that oxygen-rich blood flows into the right atrium of the heart. And right there, it meets our second shortcut, the foramen ovale. This thing is basically a small flap, an opening between the right and left atria. It directs that premium blood straight over to the left side of the heart, completely bypassing the right ventricle and the useless lungs. Why? So it can be pumped immediately to where it's needed most, the brain and the heart itself. Okay, but what about the less oxygenated blood, the blood that's already been circulating around the fetus's own body? Well, that also ends up in the right atrium. It gets pumped into the right ventricle and then heads towards the lungs. But remember, the lungs are collapsed and offer super high resistance. It's like a dead end, so the blood needs an escape route. And that is our third shunt, the ductus arteriosus. It connects the pulmonary artery directly to the aorta, diverting this blood away from the lungs, sending it down to the lower body, and eventually back to the placenta to get refreshed. So you see, it's this incredibly elegant, complete circuit. The oxygen-rich blood from the placenta gets an express lane, using the ductus venosus and foramen ovale to go straight to the brain. At the same time, the less oxygenated blood uses its own bypass, the ductus arteriosus, to also skip the lungs and head back to the placenta. It's a perfect self-contained loop. For 9 months, this amazing system just works flawlessly. But here's the kicker. It's all temporary. The entire thing is designed to become obsolete in the most dramatic way you can imagine. And it's all triggered by one single pivotal event. And that event is the baby's first breath. In that one moment, the entire world changes. The system that was so perfectly designed for life in fluid has to instantly switch to a completely new blueprint, one designed for life in air. That single breath kicks off an insane, immediate cascade of events. The first gasp of air forces the lungs to expand. Boom! The massive resistance in the pulmonary arteries just plummets. Blood rushes into the lungs for the very first time. At the same time, the umbilical cord gets clamped, cutting off the flow from the placenta. And all of this causes a dramatic reversal of pressures inside the heart. Suddenly, the left side is higher pressure than the right. And that pressure reversal, that's the signal. That is the precise trigger that starts shutting down the old fetal highway and activating the brand new blueprint for what we call adult circulation. And the difference is like night and day. The entire blueprint flips on its head. Where do you get oxygen? The placenta is out, the lungs are in. What about the lungs themselves? They go from being bypassed to being absolutely essential. And those 3 critical shunts? Their job is over. The whole system has been permanently rewired. And this shutdown isn't chaos. It's a very orderly biological sequence. That pressure change slams the foramen ovale shut almost instantly at birth. Then, over the next day or two, the higher oxygen levels in the blood trigger the ductus arteriosus to close. The other structures follow, shutting down for good over the next few days and months. So what happens to these once critical highways and doorways? They don't just disappear. They actually transform into relics, permanent ligaments and anatomical markers left behind. The foramen ovale becomes the fossa ovalis, just a little depression in the heart wall. The great ductus arteriosus becomes the simple ligamentum arteriosum. They leave behind these silent echoes of our very first circulatory blueprint. Think about that for a second. The single most profound, most complex physiological transition of your entire life happened in the first few seconds after you were born, all kicked off by one breath. It's just a powerful reminder of the incredible adaptive machine you get to live in every single day. It kind of makes you wonder, what else is it capable of?